residuals. The difference between what we predicted according to our best fit line and what we actually got. So if I squared each of these, I would get 0 plus 4 plus 4 plus 0. My sum of squared residuals would be equal to 0 plus 4 plus 4 plus 0. I would have sum of squares residual 8, which is not too bad. Okay? If I picked a different line, I would have a different sum of squares residuals. Let's look at this one. Y hat is equal to 1 plus 1.6x. Okay, so I have x, y, and then if I use y hat is equal to 1 plus 1.6x, here I would predict 2.6. And at 2, I would predict 4.2, and here I would predict 5.8, and at 4, I would predict 7.4.
Where'd you come up with that equation?
I just made it up, but that's because I know where I'm going.
Okay.
All right. I'll show you how I got this in a moment here, okay? So my residuals are negative 0.6, 1.8, negative 1.8, and 0.6, right? So my squared residuals, 0.36, 1.8 squared is something. 3.24. So my sum of squared residuals here is equal to 7.2. Okay. And just to illustrate what's going on, is basically this point says, according to the line, I am predicting that at x equals 1, the value should be 2.6. But what it really is that valued at 2. So this is the distance, that's my residual, and if I square it, I have that much. For x equals 2, I'm predicting the value to be 4.2, but my value is actually 6, so that is my difference there, and if I square that residual, I get that. Over here, I'm getting a squared residual of this size, and over here, I'm getting a squared residual of that size. Illustration's a little odd. Okay. And over here, I'm doing the same thing. Here, my residuals are 0, so I have no difference there, and over here, my squared residuals look like that. Because of the inaccuracy of my picture, the boxes magnify my error, but the idea being the total sum of squares here is 7.2, and the total sum of squares for this line is 8, so that means this is the better line. This line is better than this line. Okay. So with ordinary least squares regression, we would choose this line. Okay. Now, of course, these are not the only two lines that are available. you'd have to try thousands of them, and you'd have to figure out the squared residuals, okay? But we don't want to do that, so I'm just going to fast forward to the answer that a bunch of other smart people figured out for you. And they said, well, if you want to create the least squares regression line, the least squares regression line least squares linear regression will always pass through the point x bar and y bar, and we'll have the slope standard deviation of y divided by the standard deviation of x times r. Okay. In statistics, we say the prediction line is y hat is equal to b0 plus b1x. b0 is my intercept, and b1 is the slope. So you would say my slope, b1, is given by this formula. R is standard deviation of y over the standard deviation of x. Okay. And then if you put this in the point slope form and you solve for the intercept will always be equal to y bar minus b1 times x bar. Okay, and so that's how I came up with this line, y plus 1.6x. Because of my data, when we were looking at the bedrooms and the closets, we knew that x bar was 2.5, y bar was 5. We had a correlation of 0.8. And the standard deviation of y was 2.5 something. 2.1 equals 582. So plugging that into our formula, we would get b1 is equal to 0.8 times 1.6. Putting it all together, we get y hat is equal to 1 plus 1.6x. Yes.
Where did in the equation for b naught, where did the value of the mean y value come from in the equation? Like how did you?
The y bar?
Yeah.
The y bar and x bar? That just comes from your data. Okay? So
No, but I mean like when you found that equation for it, where did you get the y bar? Like algebraically.
Oh, algebraically?
Yeah.
Okay, so if I told you that so I told you least squares line will always pass through x bar y bar and will have the slope r s y s x. Okay, that's what the smart people figured out. So we can just go with that, alright? So if you accept that as truth, and it is true, okay, do you remember point slope form from algebra or something? What was that? That was that you would say y minus y1, is that what you would say? Y minus y1 is equal to the slope m times x minus x1, right? Does that sound familiar? Okay, so if you plug this in there, okay, so you say it's going to pass through y bar, y minus y bar, and this is going to be equal to m is now, I'm just going to plug in v1 times x minus x bar, okay? Now we're trying to solve for y in terms of x. Now I messed myself up here. Okay, but if you solve for y, you get this. Now what do they do? Yeah, so I get sorry, I just got cut off, but it I can't solve this. I think this is the point slope form, right? Oh, okay, so I'm sorry. So we're just putting this into the form y equals mx plus b, right? So basically I'm just going to add y bar to both sides and I get y equals b1 x minus b1 x bar plus y bar, right? Okay, so now I'm just going to say this I can write into the form y equals mx plus b, and b is this value. Then that is where I get y bar minus b1 x bar. Right? So now this is in point slope form, and this is, what's the other form where it's y equals mx plus b? What's that called? Slope intercept form. Okay. So we're just going from point slope into slope intercept, and then we see that the intercept is this. That's all. Okay.
I have a question.
Yes.
So that little x after the 1.6 and the 2, 6, so it just stays there.
Yeah, because
No, I'm not-
this is it's an equation of a line. So you plug in an x and you get a y. That's what we're saying.
Oh, okay.
Okay. And there's a hat on the y because the hat indicates it's a prediction. Okay. It's not the actual value of y. It's the predicted value of y. Okay. And so the last thing I need to talk about is just the interpretation of the intercept and the interpretation of the slope. Okay. So the interpretation of the slope is how much you predict y to change when you change x by 1, or increase x by 1. So in our bedroom closet interpretation, we would say if we find a place with one additional bedroom, we predict the number of closets to increase by 1.6. is our prediction for y if x had the value of 0. Okay, and sometimes it doesn't always make sense for x to have a value of 0. And in that case, you do not have a meaningful interpretation for the intercept.
Like in this case.
Yeah, so can you have a place with 0 bedrooms? Technically, yes. There's like studios. How many closets would you predict that a studio has? According to our
One.
regression line,
4.
we would predict 1 closet to exist in a studio with 0 bedrooms. That kind of works out actually, but you know, if you're trying to predict the height or weight of someone based on their height, it doesn't make sense to have a person with 0 height. And so in that case, the intercept would not have a meaningful interpretation. A few warnings regarding linear regression is that it's a useful tool, but it will not solve everything. Okay? The existence of correlation does not mean there is a cause and effect relationship. So correlation is not causation. It might indicate something that you should investigate. There might be a causal relationship somewhere. It might indicate something to investigate. But correlation in of itself doesn't indicate causation. Don't use correlation to try to make predictions outside of the range where you have collected data. So, for example, maybe you are studying the relationship of the height of a child to the age of the child. Both are numeric variables of a relationship. And you study this, and every year from ages 0 to 10, the kid gets taller. Okay? So maybe you find a very strong relationship. R is 0.9 or something. And it's like every year the kid grows by 2 inches or something. That's 2.5 inches, whatever. Okay. You cannot use that regression line or whatever to make predictions for how tall this child would be when he's 50 years old. Okay? Because even if it's linear for this portion, you might not, that linear relationship might not continue forever. And we know human height, people grow and then they stop growing. So, yes?
But how can you make interpretations if we already found out that it's not a significant correlation?
Okay, well, if it's not a significant correlation, you can still have a regression line. And it just means that the interpretations might not be entirely trustworthy or valid, okay? And that happens a lot. Okay? So everything comes with a warning. Okay? That's pretty much all of statistics, actually. Everything comes, the answer is it always depends. But, okay. Do your reading, the book talks a little bit more about linear regression and other stuff. And that will end a little early today. I'll see you guys